Hey everyone, and welcome back to this channel. If it's your first time here, thanks for watching. This is the Net Academy. I'm David Townsend, and on this video what I'm going to be going through is ISIS, or Intermediate System to Intermediate System. Now this is actually a brand new routing protocol for me. I've not had any chance to actually get to experiment with it and configure it, so this is going to be learning for all of us, but that's why we're here, huh? But what I am going to be doing is going through the basics of ISIS. Obviously, just like anything, we want to get to those advanced levels where we start talking about metric tuning and route leaking and route summarization. But before we get there, we need to start off with the basics. So during this video, what I'm going to go through is, what is ISIS? What are those levels? How is it different, but also similar to OSPF, and a little bit more detail in this ISIS routing protocol. So let's get going.
And so here's the lab that we're actually going to be using for all these videos I'm going to be doing on ISIS. IS, as I said in the beginning, stands for Intermediate System to Intermediate System. As you can see here in this lab, and we may tweak it as time goes on and we start getting into the advanced stuff, but now it will do. As you can see, we've got these areas. We've got areas 1, we've got area 0, and we've got area 2. Now, if you're familiar with OSPF, or Open Shortest Path First network in the routing protocol, you will understand the concept of areas. It allows a hierarchical architecture where you've got area 0 being that backbone that connects all non-backbone areas to each other through area 0. And ISIS is exactly the same in that concept, in that it is hierarchical by nature. But one of the differences with ISIS to OSPF is that we don't actually need the backbone to be area 0. Yes, absolutely, we still need a backbone, but it doesn't have to be area 0. It could be area 3, 4, 100, whatever. But really, for good practice, I would suggest, when you look at OSPF where it has to be area 0, the backbone, I would suggest that actually in ISIS, you have that backbone as area 0 as well. It's just good common sense in my opinion, but of course, each to their own. So that's one of the similarities between ISIS and OSPF. What are the other similarities? Well, both actually have the shortest path first algorithm, which uses, if I spell it right, DAJKSTRA, the Dijkstra algorithm. It's a bit of a tongue twister, I know. But what this basically allows is, and our end goal is to allow R1 here to communicate all the way over to R8. What it does, the Dijkstra algorithm, is it calculates what is the shortest path to get from the source to the destination. And as you can see here, R1's got quite a few routes open to it. Obviously, in 2 only initially, it can either go here or it can go there. But once it gets to these 2 other routers, it could go down here and up there, or from here down to there and up there. The list really goes on, and that's why I built this network. But the shortest path actually determines, based on a metric, what is the shortest path, what is the best path to get from that source to destination. And both OSPF and ISIS use this SPF algorithm, the Dijkstra algorithm, so that's another similarity. And of course, both of these are interior gateway protocols, i.e. they're designed for inside an autonomous system. Now, when we look at ISIS, where do we typically see this being utilized? Well, it's being utilized a lot in the service provider networks, but also it's becoming more and more known in the enterprise network as well. Why is this? Why is it not moving, but why is it now starting to be seen more in the enterprise network? Well, there's this concept of underlay, let's write this out, and overlay. And with overlay, there's many protocols here, but a very popular one these days is a protocol called eVPN. So eVPN is an overlay protocol which allows geographically separate networks, LANs with their separate VLANs, etc., communicate to each other over a layer 3 routed network. And if you know the networking stack, you know that's not traditionally possible. That's where the overlay comes into it. But to allow these networks to see each other, for the overlay to have that peering, we need a underlay protocol. And that's where protocols like IS, and OSPF, etc. really come into it, because they allow that underlay connectivity. So from a service provider's network, what we can do is allow the IS network to build the connectivity from all these different routers, so that they can build the connectivity. They can see who's connected on the underlay. If we've got a BGP speaking router here, we've got another BGP speaking router over here, connection to end customer networks. These are really learning that internet, the internet itself. Over here would be one autonomous system, over here would be another autonomous system, and these just want to get connectivity from here all the way over to here, maybe with route reflectors in between, etc., etc. BGP is a whole different topic, but without the underlay protocol, that's just not going to work. And where ISIS is so scalable, future-proof, and really secure, it's a perfect routing protocol for service provider networks and enterprise networks who are now starting to look at other protocols such as EVPN. But let's get back on track with ISIS. I'm just going to clean up my screen a little bit here. And so very quickly there, we've covered some similarities between OSPF and IS, i.e. areas. We have this area concept, and we still have this hierarchical architecture like we've got in OSPF. However, with the areas, and what I should say, is as you can see here, we've got area 1 here and area 0. With OSPF, you'd see that router straddling those different areas themselves. And this would be known as the ABR, the area border router. Now, we still have ABRs in ISIS. They absolutely still exist. But these are the ABRs here, 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 and actually here. But you can see they're not actually straddling the networks, the areas themselves. The difference being is that we actually define the interfaces into what's known in ISIS as different levels. And we'll come on to the levels in just a few minutes, but that is one big difference between OSPF and ISIS, where the ABR actually straddles between different areas and has that one link state database for basically everything and all the different areas in there. With ISIS, it approaches it a little bit different. And I mentioned a key word there, link state. So ISIS, just like OSPF, is a link state routing protocol. It looks at the links and divides the metric, the cost to get from that source to destination. And when you've got a link state, you have a link state database. So both OSPF and ISIS have areas, use the shortest path first, and have a link state database. But where ISIS actually differs from OSPF is it works really, 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 really hard to keep these different levels, come on to that in just a second, works really hard to keep these levels away from each other. So we actually have in ISIS a link state database for level 1 and level 2. But what are these different levels? Well, most people who know the basics of ISIS, maybe more of the advanced stuff, will typically speak about 2 levels within ISIS, i.e., as I've just said, level 1 and level 2. But there's actually 4 levels in ISIS. You've got level 0 and level 3. But those are just numbers. What does this actually mean in English? Well, just like in any network, we have got our end users, haven't we? I'm just drawing, I'm terrible at art. Here's your end user or some kind of server. Let me try and draw this. Oh, I'm terrible. But you get the idea. It is an end system or ES. And over here you'd have another ES. I'm just going to write out ES there. Now the ESs will connect to that switch, which will eventually connect to a router somewhere. So I'm just going to connect these guys in straight into these different VMX routers. So we've got ES to ES. Now that is actually a good point to build on. What is a ES? Well, as I said, it's an end system. But when you look at an end system, it can transmit and it can receive only. It's transmitting to the intermediate systems, which are these VMX routers that you can see all throughout this network here. It's an intermediate system. So So they are transmitting and receiving only. But when you look at an IS, intermediate system, these can transmit, these can receive, but they can also forward. Now that's very important because that's what's going to allow VMX1 to communicate to VMX8 or R1 to R8, hopefully at the end of this video. But coming back to this level 0 is really the end system to the first intermediate system communication. So the end system, that server, that host, whatever it may be, is trying to communicate to whatever destination and is communicating initially to that intermediate system itself. What is level 1? Well, before I actually go through what level 1 is in terms of communication, you've got level 1 here, and guess what? Here, you could think in level 1 here, you'd be wrong, it's actually level 2. So the difference between is level 1 is really a intra, if you think about OSPF, is an intra-area communication. So it's R1 here communicating down to R3. It's R1 communicating up to R2. It's R2 communicating down to R3. It's staying within the same area. Now, obviously, when we look over here, area 2, there's not much in this area. But when we look at area 0, i.e. the backbone, you can see there's a lot of connectivity here. And level 2 is really inter-area communication. So this is where we've got the R2 and R3 communicating over and via these different links here into area 0 using level 2 communication. So when we look back at what level 1 is, this is intermediate system to intermediate system, but it is in the same, I just write here, same area. Level 2 is also intermediate system to intermediate system, but they are in different areas. So as I said, that's where we've got R2 and R3 in level 1, in area 1, communicating to all those routers in area 0. Level 3 is a little bit different. If here we've got a connection which goes off to another intermediate system, another ISIS autonomous system, or a completely different network which is running an external routing protocol, this is where level 3 would come in. So this is where we're going to get into a bit more of an advanced topic, and this is something we'll cover in a later video. This is really for those external connectivities, bit of a tongue twister there. So we've gone through quite a lot of information initially in terms of where ISIS is typically seen, the underlay and maybe an overlay going on top of it, which is why it's so popular in service provider and now growing in enterprise networks as well. We've gone into the similarities in OSPF to ISIS and vice versa, and we've started to introduce the concept of these levels. And ISIS loves the levels, and it has rules which we're going to go through here, which is very important to remember when it comes to ISIS. When we look at level 1 as a rule set, they can communicate only to other level 1 routers or interfaces really on that router itself. When we look at level 2, they can speak to other level 2 speaking interfaces on that router, but they will be in a different area. So as I said, level 1 is really intra-area, like OSPF. When we're talking level 2, we're talking inter-area communication. So level 1 is intra-area, in the same area. Level 2 is inter-area, in different areas. Okay, so let's put this into a little bit of theory. Here we've got area 0, and as I said, every interface in area 0, the backbone, again, it doesn't have to be area 0, but that's going to be level 2. So we're going to have level 2 here, level 2 here, level 2 here, level 2 here, here, and the list absolutely goes on and on. But if we look at area 2, moving away from area 1, because it's a little bit interesting over there, as I said, here in area 2, we've got intra-area communication. So naturally, wouldn't this then be level 1 speaking interface here and here? But if this is level 2 here and this is level 2 here, then looking at this rule set, this is not going to work because level 2 cannot speak to level 1 interfaces and vice versa. As I said, ISIS works really hard in keeping these levels completely separate. That's why we've actually got two different link state databases, one for level 1 and one for level 2. So when you've got these interfaces that are pointing, moving, connected towards that backbone, whatever that backbone might be, these would actually be level 2 speaking interfaces themselves. If there was another router just over here in that same area, then here we'd have a level 1 connection here and a level 1 connection there. So it's very important to remember those rules themselves. And as I've said a few times, ISIS has one link state database per router, of course, for level 1 and one for level 2. So when we want to get R1 to speak to R8, we've got a level 1 here, we've got level 1 here, area 1, area 2, they're both level 1s, and here we've got level 2, which is always recommended to be that backbone, just to allow the connectivity, the hierarchical nature of ISIS, just like OSPF. But when these level 1 routes come into level 2, area 0, ISIS will automatically and naturally import those routes from level 1 into level 2. And then this route will just go through the network here. I'm just using this path here just for example. But what happens when this route gets to R7 and needs to go down to R8? We're going here from a level 2 into a level 1 network, even though this would be a level 2 interface here. If that was an end system or another router, at the end of it, it would be level 1. But what happens here is quite different with ISIS when you look at OSPF, is that when we are moving, exporting routes from level 2, vice versa in the opposite direction back to level 1, this is not allowed. It simply doesn't work. So level 1 routes can automatically be imported into that level 2 link state database. However, level 2 routes are not automatically exported into that level 1 link state database, and that's where route leaking, it's more of an advanced topic, actually comes into it.
So let's just go onto a whiteboard just for a minute and actually talk about the type of addressing that ISIS actually uses. And as you can see here, I've actually wrote down what's known as the NET address, or Network Entity Title address, for R1. And let's also go through why this kind of addressing, why this protocol came around. And let's actually start off there. As I might have mentioned, the ISIS came from a standardized body called the Institute Organization of Standardization. I think it was what it's called, or ISO. I know that doesn't make much sense because it's the Institute Organization of Standardization. It should be IOS, not ISO. But nonetheless, this is what it's actually called. And they really defined the ISIS routing protocol to be a connectionless networking subsystem, or CLNS. It's connectionless, hence you don't need theoretically IP or INET or Internet Protocol addressing technically for this to work. But as you'll see on the configuration, that really we actually do kind of need it to work. You can build adjacency without IP, but to really see that end-to-end visibility, reachability, and to do things like traceroute, it's really good to have IP addressing. But it was really created to compete against that IP protocol, Internet Protocol, IP. And the address is what's known as the Network Entity Title, or NET address for short. And this is what the actual address looks like, and it's made up of quite a different few areas. For ISIS, it always starts with 49. Now this is what's known as the address family indicator. So the AFI for ISIS is always going to be 49. As far as I'm aware, it won't be anything different. So whenever you see 49 as a net address, you know it's ISIS. And this is 1 byte if I remember correctly. Here we've got a number of bytes. I think it's flexible. But here really what we're concerned about is this identifies the actual area. So 0001 identifies it is area 1. If we wanted to talk about one of the routers or intermediate systems, I should say, in area 0, it would be 0000. If we wanted to talk about R8, which is in area 2, it would be 0002. So here we basically identify initially from here to here that this is an ISIS speaking entity and it is in area 1. Here though we then start to identify what is the system ID. Now what the system ID actually does is it identifies a particular system, an intermediate system within an area for ISIS, indicated by the 49. Now you've got different ways of actually populating this, because as you can see it's 1, 2, 3 different 4 hex values or areas, however you want to call it. So here what I've taken is the 172.168.0.1 and I've actually put that into its system ID. I've just buffered it out by entering an extra 0 here, there and everywhere, or you could actually take that system ID's MAC address, put it in here, but where the MAC address isn't big enough in terms of bytes, you're going to then have to buffer it out a little bit, which is why I think a lot of people, a lot of companies would just take that IP address and put it into the system ID and fill it with a few zeros here and there. So that is the system ID. Now here is what's known as the network selector, or NSEL. So here is where the CLNS define a number of different services. Now as far as I'm aware this should always be 00. However, it can change depending on that type of service. But for these purposes, what we're actually going to do is just configure it nice and straightforward for it to be 00. So this is that network entity title, that address. This is what ISO uses. And when we go onto the interfaces and on the loopback address, on the loopback 0 address, we are going to define those interfaces and that loopback interface to use family ISO. We're not going to define them initially to use family INET. So this is what ISIS uses in terms of its addressing. As you can see, it's completely different to Internet Protocol, IPv4 and especially IPv6 addressing.
I'll tell you a bit of a lie, a little bit of a porky. We're actually going to get into the configuration right now. So I've got my secure CRC up, and as you can see, I've just logged into all the different routers, and that's actually what this little globe here actually allows. This allows my external network to connect to this network. If you've ever wondered what that is, that's basically what it does. It's just bridging it all together. But I'm on R1 and I need to configure basically everything. So if I go into CLI and just do a show interfaces first, and what we can see is that right at the top, we've got all our gigi interfaces, etc. They're all up. There's no real IP addressing set. If we look at the loopback 0, we can see it's up, but it doesn't have any ISO address, not even an INET address. If we do a show protocols, or let's do show ISIS, do question mark, and let's just do a quick brief, shall we, or database. There's nothing there because not even the IS protocol has been defined. This is very much a fresh greenfield installation as well. So let's go into configure mode. Now what I need to do first is define, and I'm only going to do this for 3 routers. You really don't want to see me going through all 8 routers. It's going to be incredibly boring for you. So I'm only going to do R1, R2 and R3 just to begin with for you. So I need to configure the loopback 0 interface first. Again, the adjacency, the reachability is via the loopback 0 unit 0 interface. You can and should have an INET address assigned to that for extra reachability in terms of the overlay, coming back to the overlay protocols, very important. But we do need the ISO, the International Organization of Standardization, which defines that network entity or NET address defined on that loopback 0 interface. We don't define that on the interfaces themselves, but we do define that on the loopback interface. So So let's do set interface loopback 0.0 family ISIO. And if I hit question mark now, we now need to enter in a particular address. Now that's why I've actually put in all the addresses here. So R1 net address is 49. Again, that is just the AFI address family indicator for ISIS. And then we need to enter in the next 4 hex values, 3 bytes, which is the area. So R1 is in area 1, so we're going to do 0001. And now we need to enter in that system ID or system identifier. As I said, you can do this in many different ways, via a MAC address and buffer it out, or an IP address. That's what we're doing here. So I need to enter in 172.0.168.0.0001. And finally, that network selector, those services just defined as 00 here. So if I enter that in here and now do show interfaces loopback 0, you can actually see that I've got that ISO address configured for loopback 0. Again, it's good practice to have an IP address assigned to that loopback interface as well for reachability. So I'm just going to hit up and do set interfaces family inet address, and I'm just going to give it 1111/32. And if I hit that same shell command again, I've now got my inet address, my IPv4 address on loopback 0, as well as my family ISO, my ISIS net network entity title address assigned to loopback 0 as well. So that's one of the first things that we need to do in terms of basic configuration. So with the loopback 0 interface defined, with the inet address, with the ISO address, the net address, we now need to go to the next step. And you can do this in whatever way you feel is needed, but for me this makes sense to then define the protocol itself. So I'm going to go to edit protocols, ISIS, and if I do a quick show, you can see there's nothing here. Now if I do set question mark, you can see there's a lot of configurations we can do. So overload, we'll come on to that in a separate video. Topologies, trace options. The one that we really want to concentrate on, and I'm really just going to use initially, is this interface command. We need to define the interface that we want R1 to send those ISIS packets into or out of, and also to receive on as well. And looking at the topology, you can see that it's the GigE002 interface and the GigE003 interface. So if I do set interface GigE002.0, so that's the unit 0, and then I need to give this a particular level. Now, what level is R1? Are these interfaces on R1? All of this, GigE002 and 003, going up to R2 and R3 respectively, it's in the same area, it's intra area. Now, thus, it is a level 1 connection. Now, it's a little bit backwards on Junos when it comes to configuring ISIS, because what we need to do is actually not say level 1, but we actually need to say level 2 disable. We are basically saying, with this configuration, we don't want to build level 2 adjacency over the GigE002 interface because we've disabled it, but we've not disabled level 1 over this interface, and thus the level 1 adjacency will be built between R1 and R2 because we haven't said level 1 disabled, we've said level 2 disabled. And that's a big point there, it's actually over the same interface you can have level 1 and level 2 adjacencies actually built. Again, remember, ISIS has 2 different linked state databases, one for level 1, one for level 2. But even over the same interface, and this is actually what we're going to do between R2 and R3, is we're actually going to build an R1, a level 1 interface, and a level 2 adjacency over the interface as well. So coming back to here, if I just enter that in, hit up, and I need to enter this onto the GigE003 interface as well. Now if I do a quick shell command, you can now see that we have pointed the protocol ISIS out of interface GigE002 and GigE003, and both of them are disabled for level 2. They will only work as such for level 1. But it doesn't stop there. We also need to define a little something on the interfaces themselves. So if I go to the top and just do set interface GigE002.0 family ISO, we don't define the net address here. we've done that on the loopback 0, and all routers will see, R2, R3, etc. will see R1's net address that we've defined on the loopback 0. But we basically need to define here that we want that GIGI002 and GIGI003 interface to speak that language of ISIS that has been defined by the ISO. That's really what we're doing here. So if I hit up and do the same for GIGI003, and that is basically it. If I do a quick show compare, then we can actually see, I love this command, you can actually see we're entering in the GIGI02 to be family ISO, GIGI003 to be family ISO. We've defined loopback 0 to use a particular IPv4 address, 1111, very straightforward. Also defined that network entity title or net address for the ISIS connectivity, for the reachability. And we've defined the protocols. So ISIS to use GIGI002 and GIGI003 at level 1 only, because level 2 is disabled. And now if I do a quick commit check and it succeeds and pushes configuration, and whilst that's doing that, I'm actually going to go into R2 and do exactly the same thing, a little bit more quicker. So if I go into configure, let's do set interface loopback 0.0 family ISO address 49.area1 172.0.168 0.000.2.00, and that is the loopback 0 actually defined. We now need to define set protocols ISIS interface GIGI 001.0, so this is going to R1, level 2 disable. And I hit up, do the same for GIGI 003, but with GIGI 003, we want this to be both level 1 and level 2. So therefore, we are just going to not actually say level 1 or level 2 disabled. And if I go up again, we also have the GIGI 005. That's going into area 0, which is level 2. So now I need to define this to be level 1 disabled. And again, of the GIGI 004 interface, which is going to R4, and that is a level 2 network. It's the backbone, and I need to disable level 1 on that. But just as before, I need to define the interfaces to speak ISIS to use that family ISO. So GIGI family 3, family ISO, done. And I also need to do the same on GIGI 3, GIGI 4, and GIGI 5. Now if I do a quick commit check, and it has succeeded, and I'll run that configuration and now go on to the final router R3. This is why you don't want me to see doing the same on R4, R5, R6, R7, R8, because you are going to get bored. You'll leave this video very quickly. So let's just go into configure, and let's do set interface loopback 0.0 family ISO address 49.001. Position area 1 172.0. Keep doing that. 168.0.003.00. Now I need to define set protocols ISIS, and the interface GIGI 001.0 is a level 1 interface. I need to say level 2 disable. We also have its ISIS going out of the GIGI 002 interface. But just like we saw in R2, it's using both level 1 and level 2. So I'm just going to say set protocols ISIS interface GIGI 002, and I'm not going to disable level 1 or level 2. But we do have level 2 connectivity out of GIGI 004 and GIGI 005, and therefore I need to disable level 1 out of GIGI 004 and out of GIGI 005. And if I do a quick commit check and it passes, run this configuration, and once that has run, what we should see, going back to whichever router, R1, R2, R3, doesn't matter, is we should then see an adjacency built between these different routers, and as you can see, that's now committed. And I'm a bit silly, this is what happens when you try to go too fast. I forgot to configure the family ISO on those interfaces on R3, so they can actually speak that ISIS language, understand and send and receive those different packets. So let's do set interfaces GIGI 001.0 family ISO. Let's do the same for GIGI 002, GIGI 004, and jncia-ent-5. And now I will commit that as the final configuration. So let's go on to R1 now and see has it actually got that adjacency from R1 to R2 and R3. So if I just quit out of here, let's do a show ISIS, hit question mark, how can we see, do we have adjacency? Well, obviously it's right up there, show ISIS adjacency. And there we go, you can immediately see we've got connectivity at the GIGI002 and 003 interface to system. I love this, it just says system R2 because that's the host name on R2. It's really clever. We can also see we've got the adjacency to router R3. You can also see both these are level 1. The state is up. We can also see the hold down second. So this will decrement from a particular value, and then another hello packet will basically refresh this. And you can also see the SNMP A address, which we'll come on to in a separate video. And just to go back to that hold timer, you can actually see it's changed here. So although it's counted down in seconds, if I keep doing this, you're going to see it will slowly start counting down. So it will count down from a particular value, and if it doesn't hear from its neighbours in that particular hold time, it will just tear down that adjacency. Well, what else can we actually see to see detail into this OSPF adjacency? Well, if I just hit return a few times just so we get a little bit of space and do a show ISIS routes, so all routes that have been learned by ISIS, you can see there's nothing. So that's concerning, but there is a reason to this. If I do show routes, the good old command there, you can see in the routing table, R1 has got its INET address that's assigned to the loopback 0. We can see this is just my management network here, so just forget that. But here we can also see the ISO address that's assigned to the loopback 0. Why can we not see R2 and R3? Can we ping their addresses? Because again, we've got full adjacency, haven't we, to R2 and R3? So can we ping those loopback 0 interfaces? So, and actually that's a good point there, I didn't actually configure the INET addresses on the loopback interfaces. So if I go back into configure mode and do set interfaces loopback 0.0 family INET 2.2.2.2/32 address, second time right, and I'll submit that configuration, go over to R3 and do the same, so do set interfaces loopback 0.0 family INET address 3.2.2.3/32, commit this, and now those configurations have succeeded. Let's go back to R1, and if I run those same commands again, let's do show route, you can see we still do not have 2.2.2.2, we still don't have 3.3.3.3. Now coming back to what I was saying, can we ping 2.2.2.2? Obviously the answer is no, because it's not in the routing table. So even though ISIS has built an adjacency between R1, R2 and R2 to R3, etc., the adjacency is up, it's there, it's working, but they're not passing TLVs, they're not passing packets in terms of learning each other, because we don't have INET addresses, IP addresses on the interface themselves. So even though it does work, it's only going to get you so far if you do not have IP addressing actually configured on that on those GIGI00 interfaces. So that's actually what we need to do now. So what I've done is I've just defined the IP addressing that we're going to be using on the interfaces between the different routers themselves. Just very quickly, we need to configure this. So if I now do set interfaces GIGI002.0 family INET address 200.10.20.1/30. And I need to do the same on GIGI003, but this needs to be .5/30, 3.5/30 out of GIGI003. Now commit this configuration, and let's now go over to router R2 and define set interface GIGI001.0 family INET address 200.10.20.2/30, and same again, but with a .9/30 out of the GIGI003 interface. Commit this configuration, and now if I go onto router R3, we set interface gigi002.0 family INET address 200.10.20.10/30. Also need to do the gigi001 interface, but this is a 200.10.20.6/30 out of the gigi1 interface. Commit this configuration, and as we can see, all configurations have passed. So let's come back to R1, just quit out of here. Let's see, do we still have the ISIS adjacency? We absolutely do. But note those exclamation marks, I don't know if you noticed that before, they've actually disappeared. So before, if I just scroll up slightly, you can see just here, there's these exclamation marks, just here. That was really saying, yes, I've got adjacency, but there's something wrong here. An exclamation mark is probably never a good thing. It's like a red light, in my mind. But it's saying, there's something wrong here. Yes, you've got adjacency, but this isn't really going to work. And now you can see, the exclamation marks have actually disappeared. So now let's do show ISIS root. And what we can see now out of show ISIS root is that for the prefix 200.10.20.8, I think that is, I need to get my glasses on, we can see that it's level 1 using version 12, metric of 20, and we've got gigi003 and gigi002 running IPv4. Okay, so that's looking positive. How about if I do show root now? And it's looking a lot better now, isn't it? So let me just move this up and expand this down a little bit, just so it's all on one page. So now we can actually see all the networks here. So we can see the 200.10, which is local. We can also see local interfaces and direct interfaces, but we can also see the network between R2 and R3. So that is the 200.10.20.8 network itself. Why are we not seeing the loopback interfaces on these different routers though, on R1? Why are we not seeing the loopback interface on router R2 and R3? Well, let's go back into configure mode, and this is all deliberate, of course. If I go into edit protocols ISIS and do a quick show, you can see that we've configured it for the interfaces, but we have not defined the loopback 0 to be in the protocol ISIS. So therefore, the ISIS protocol Junos is not advertising that loopback 0 interface into ISIS. So that's what's missing here. So that also needs to change. So if we do set interface loopback 0.0, loopback 0.0, and this is a level 1. So we need to level 2 disable. And we'll commit to that configuration, go back onto router R2 and do set protocols ISIS interface loopback 0.0, and this is going to be both for level 1 and level 2. So we're just going to set that to there, do a commit, and same again, set protocols ISIS loopback 0.0, commit this configuration, and now let's see how this has changed. So back on router R1, as we saw before, we have learned those different, really just the one network between router R2 and R3, which is completely not connected to router R1. I learned about it through ISIS, but we couldn't then see R2's loopback interface. We couldn't see R3's loopback interface. Again, because we didn't advertise that loopback 0 into ISIS. But now, if I just do a quick quit, come out of the config mode, go into the monitoring mode, and let's do show ISIS root. And now we can see, it looks much better, doesn't it? 2.2.2.2, level 1, version 15, metric 10, that is the default, by the way, the default cost for ISIS, just every interface has a cost of 10. So it's saying, well, for R1 to get to here, to R2 and to R3, it's going to cost me 10. But to get to R2, well, through R2 or through R3 to this network here, got one interface here, and it's a cost of 20. It's just a default cost. We'll come on to cost in a separate video. Again, all the interfaces that we can reach these networks as such. But how about that routing table? So if I do show root, now we can see, we have learned 2.2.2.2/32 3.3.3.3/32 via ISIS. The Junos cost of ISIS is not the cost, sorry, the administrative distance or preference, however you want to call it, is 15. I think in Cisco IOS it's 115. So yeah, a little bit different. But we can see again it's a metric of 10, and it is to get to here we're going to go out of this next hop. So that is the GigE001 interface on router R2 out of my GigE002 interface. And of course now we can ping these actual destinations itself.
So I'm going to stop there. I'm going to conclude and summarize what we've gone through, because there's been a lot of information, and if I start going through all those different routers and the level 2 configuration, etc., it might be too much, because this is again an introduction into ISIS. So what have we covered so far? And we have covered a lot. First, we've gone through the similarities between ISIS and OSPF, and to reiterate, both of them have a linked state database. Where ISIS differentiates itself from OSPF is that it has two, one for level 1 and one for level 2. So again, it's very, very good at keeping level 1 and level 2 completely separate from each other. Also, another similarity is that both of these use a shortest path first, the Dijkstra algorithm, to calculate what is the shortest path to get from that source to that destination. And both of these are of course an interior gateway routing protocol. But we also went through more information other than the similarities. We also went through what is the network entity title, that net address. Where is it actually configured on Junos, i.e. in that loopback 0 interface? Of course, how to configure a very basic configuration for Junos for that protocol. All we basically did was say, yeah, set protocols ISIS interface GigE whatever interface it actually was, and then disable that particular level. So if it was a level 1 interface, we'll do level 2 disable. If it was a level 2 interface, we would say level 1 disable. A little bit backwards, I know, but that's how Junos works. And of course we then done some show commands: show ISIS adjacency, show ISIS route, and show route itself. And of course a few gotchas along the way, which was of course deliberate, in that you have to advertise that loopback 0 interface into that protocol ISIS as well, so that they have that reachability to each other. So I hope you found that useful. If you like what you saw and you like this material, please like, subscribe. I love hearing from you guys as well, and stay tuned for the next video where we're going to continue going into this really great scalable and future-proof and secure protocol that is ISIS. Thanks for watching and goodbye.